Now let's try our stake validator on the private testnet. So first we need to decide what address we use as parameter. And it doesn't really matter, but the private testnet provides 3 predefined users. So let's take the second one. So this payment to address. That's this one. So I fire up the REPL and call the function we defined to serialize the stake validator once we have provided an address. So I copy this and paste it in here. And it serialized the validator into our asset folder. There it is. So now we can use this script and try it out on the testnet. Now that we have our script, we need to do a couple of things first. We have to build a stake address from the script. So this will be the first example of a stake address that we see that's not based on a key pair, but on a script instead, on our script that we just defined. Then we need to register that stake address and we need to delegate to a pool. So I provide the script for this, register and delegate. Again, because we need to craft a transaction and submit a transaction, we need an input. So this is the parameter, the txin. Then this is just where we serialize the script to. Then where I want to write the stake address to. Then I also want to use that stake address to build a payment address. And I want to have the payment part being that of user 1, but then the stake part being our new stake address. This is where I want to write the registration certificate. This is where I want to write the delegation certificate. This is where I want to write the protocol parameters, the unsigned transaction, and the signed transaction. So first I set the node socket. Now the first step is to build the stake address. For that we have the Cardano CLI command stake address build. It takes testnet magic, the script that we just created, and where to put the resulting address. Now that I have that stake address, I want to build a payment address from that. So again, testnet magic. Now the payment verification key is the payment key of user 1. And as the stake part, we use our script and write it to this file. Now I can create a registration certificate for this script-based stake address and a delegation certificate. And to do this, I must have a pool ID that I want to delegate to. So I reuse the script we saw in action earlier that lists all the stake pools and just take the first one. It doesn't really matter to which one we delegate. I query the protocol parameters, and now I can build my transaction. So era, testnet magic. As change address, I use the newly created address. So I would have other choices, of course, but by doing this, I make sure that this newly created address is actually funded. So the funds will come from the old address of user 1, the one that just used the ordinary stake address based on a key pair. And in principle, all the funds except for the costs of this transaction will go to this new address where user 1 still has the spending power, but the stake component has now been replaced by our script. I use the specified input. I can also use that as collateral. Collateral is needed because now Plutus scripts are involved. We do delegation, registration, so scripts have to be executed. Remember, the logic of our script was that for the certificates part, it always returns true. But nevertheless, it has to execute this, so we have to provide collateral. Then I attach the registration certificate I created, the delegation certificate I created. I have to provide the script as witness. So earlier, when we withdrew the rewards for user 1 with this old stake address, because it was a key-based address, as witness, we needed to sign the transaction with the corresponding staking key. Now this is replaced by providing the certificate. The redeemer remember we used unit as a redeemer, so I copied the JSON representation of unit from a previous lecture into the assets folder of this lecture. And finally, the protocol parameters. Then I sign, and this only has to be done now with the payment key of user one. And finally, I submit. So I must look up the UTXO I can use to spend. So I do the query UTXO user one again. So now this is this UTXO. Now I can call this function using this as an argument, #0 from here. And it seems to have worked. So we also see these log messages here. We have this UTXO we spent, the newly created stake address. This is now based on our script, the newly created payment address, and we submitted the transaction. So now there shouldn't be any funds left at this address, and all the funds should have moved to the new payment address we created. So we can check this. So at the original address, there's nothing, but now I also have this script, which checks the new address that we just created. And we see indeed that almost all the original 300,000 ADA are now at this address. It's a bit less due to registration deposit and transaction fees. And now we can try to withdraw rewards from this new stake address. By now, some should have accumulated already. So I created this final script, withdrew user one script. So the idea is that user one does that and tries to withdraw rewards from this new stake address. So I set the temp folder. The amount, this is as before we use the script-based stake address. So I query the accumulated rewards with this script that is here. So it's as before, except now the address is the new address we created. And extract the amount using JQ. Now I have a second amount because remember the script requires that I pay at least half of the withdrawn rewards to the specified address, which is the address of user 2 in our case. So I use the Linux expression command to actually calculate that. And I just add 1 in case this is odd. Dividing by 2 would round down, so then it would be slightly less than half. So to be on the safe side, I add 1 Loveless. Of course, now if it's even, then I pay 1 Loveless too much to user 2. Now I set the node socket, I query the protocol parameters, and I construct my transaction. So Babbage era, testnet magic. As change address, I use the new address, where I also take the original funds from. Write to this file, use the specified UTXO as input, use that also as collateral. Now I pay user 2, it's due. This is this half amount I calculated before. And I do my withdrawal. So I say from which stake address, that's the new stake address we computed with the full amount of available rewards. And I need to specify the script file in this case. And as redeemer, again, I use the unit and attach the protocol parameters. I sign again, only the payment part needs a signature because now the staking part is handled by the script. And finally, I submit. So to try it out, we first need to look up the UTXO that we can use as input. This one. Now we can try this. However, I first want to try it with the wrong version of the transaction where I do not pay user 2. So let me just delete this line and now execute the script. And we do get an error. And in particular, we see here, machine terminated because of an error, script debugging logs insufficient reward sharing. And that incidentally comes from our Plutus code. There we traced an error in the case that the specified address is not paid at least half of the rewards. So we see that indeed the script is executed and the logic is run. And in this case, the transaction is invalid because we don't pay user 2 in our case as we should have. So let me include the line again and try this once more. And this time the transaction goes through. And we see here at the moment 10,000 ADA had accumulated as rewards at this new stake address. And this is half of it, what user 2 is paid. So we can check. And user 2 indeed now has this additional payment of half the rewards. And user 1 now has more than the original 300,000 ADA because user 1 got the other half of the rewards. So this demonstrates that it works. So we can indeed use stake address that's based on a script, and then with staking related operations, we do not have to sign with the staking key as with key-based staking addresses, but instead the corresponding Plutus code is executed, and whatever logic is encoded in that is enforced. So in our case, we saw that we indeed, when we withdraw rewards from that stake address, we need to pay at least half of the rewards to the specified user, to the specified address.